Hello. We are going to go ahead and get started with our notes. The warm up is going to be on Schoology as a warm up for attendance today. So we're going to skip that. So today we are going to start with probability. This video will be broken up into two different parts. We are going to figure out theoretical and experimental probability. So this was going to be a game that we played in class. So if you have any dice, you can go ahead and play it. Otherwise, you can just use the data I give you. So it says we're going to play a game to answer this question. You and your partner must decide who will be odds and who will be evens. Then you will roll the dice and multiply the numbers. If the product is odd, the odd person wins, and vice versa for evens. Play 20 times, keep track of how many wins each person has. So I did this in my statistics class, and I got 4 wins. So I'm going to put 4 odd wins. So this is 4 out of 20 because we had 20 trials, which is 20%. This is called the experimental probability. Let's see here. So this is called the experimental probability because that's what actually happened when we ran the experiment. So we took 20 trials, 4 times the odds win. So now maybe the odds just had a run of bad luck. So let's see what the rest of the class had. So the total percentage of rolls that were odd products for the whole class, what this ended up being for my statistics class was something close to 25%. Okay, so everyone's averaged together. Some people were above, some people were below that average. So the total percent of the rolls, so maybe you had more than 25%. Other people maybe had less than 25%. So the idea is the more times this happens, the closer we are going to get to the theoretical probability. So this is the experimental probability. So this is called the law of large numbers. So the law of large numbers is basically saying that the more times we complete an experiment, the closer we're going to get to the theoretical probability. So then number 3, it says to determine the true probability of rolling an odd product, we should list out all the possible products that we could get. Complete the table below and show all the possible products. So you are going to go ahead and do that. You're going to multiply 1 times 1, 1 times 2, and so on. And then you can go ahead and look at this table when you finish. So I'm going to fill in this table. So this would be 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12, 14, 16, getting distracted, sorry. 3, 6, 9, 12, 15, 18, 4, 8, 12, 16, 20, 24, 5, 10, 15, 20, 25, 30, and 6, 12, 18, 24, 30, 36. All right. So That's the table for finding an odd product, or finding the products. So now we want to find the probability of rolling an odd product. So this is all the top possible products we can have. So we want to count up how many odds there are. So how many odds over how many total outcomes. So when I count up the odds, I find that there are 9 odds and there's 36 total outcomes, which is 1/4, which is 25%, 0.25. So this is the theoretical probability. So number 4, theoretical probability. So that means that's what should happen in the real world. So, or not in the real world, and theoretically, in the perfect world, this is what should happen. So we saw that with the law of large numbers, it got close to 0.25. We didn't actually get to run the simulation here, but the law of large numbers means that the more times I complete it, the closer it gets to theoretical probability. So theoretically, I should get this 25% of the time that odds win, because it only happens 25%. So number 5 says which was closer to the percentage you found in number 4, your class data or your group data or the classroom data. And why do you think that is? So the class data is closer because there are more roles. Oops. All right. Now you're going to use the table to find the probability of rolling each of the following products. So a 4 or a 5. So you're going to count up how many 4s or 5s there are. So I see 4 in there 3 times. So 3 out of 36 plus the 5 is in there twice. 2 out of 36. So when I add those together, I get 5 out of 36. And then a number besides 6. So one way we could look at this is finding how many 6s there are. And I see 4 of them. Now, 4 out of 36 is what the probability would be for a 6, but we want besides 6, so if we were to count up everything else, it would just be 1 minus that, or 36 minus 4, which is 32 out of 36, or 8 out of 9. So the reason we do it that way is because then I don't have to go through and count how many are not 6s. I just count how many are 6s and subtract 36 minus 4, or 1 minus 4 out of 36. So this is called the complement rule. So this is a complement, and we'll take notes on this on the next slide here. This is our or. So if you remember, or meant adding. So we found the probability of a 4 or probability of a 5, and we added those together. Then we wanted a number from 1 to 36. So if we look at from 1 to 36, there are no other numbers that I could get besides 1 through 36. So that is going to have to equal 1. So the probability of all of them happening together is 1. The probability must add to 1. So that is another thing we know about probability, is that in the sample space, so this is all of the possibilities, that's called my sample space. All of the possible outcomes, we've talked about that word before already, but all the possible outcomes, the probability of all of them happening, that probability must add to 1. Okay. So now we are going to take a few notes on the next page. So the probability of an event is the measure of the likeliness or the chance that an event will occur. So the theoretical probability we talked about was the number of favorable outcomes over your total number of outcomes. So back in this example, my total number of outcomes is 36, and the favorable was 9 for odds, because that's what I wanted to find. Back here for experimental, it was my number of trials is 20, and the number of times I got a success was 4. So odds winning. So number of successes over the number of trials. They're essentially the same type of thing. And remember, the law of large numbers tells us that the experimental probability will approach the theoretical probability the more times I do it. Okay, so then what I want to encourage you to do is stop the video here and do 1 through 4 on your own. And then we will reconvene together. I am going to go ahead and stop the video here, and then I'm going to start a new video for the check your understanding through the end of the notes. So 1 through 8 will be in a second video. That way you can kind of take a break here, work on number 1 through 4, and then you can see the explanation in video number 2.